Okay, we're going to add and subtract rational expressions. See if I can get this to focus. There we go. All right, so the first example, they'll already have a common denominator, but that's something you have to keep in mind whenever you're adding, subtracting fractions. They have to have the same denominator. So let's see, something like this. So when you look at this problem, I have 7y over 2y to the third power plus 3y over 2y to the third power. They have the same denominator, so I keep the denominator, and now I look to see if these are like terms. So I can add 7y plus 3y and get 10y. Now you have to simplify this, and the 10 and the 2 become 5 over 1, and you subtract your exponents here. Okay. And when you subtract, you get 1 minus 3, which is negative 2, but I can't have a negative 2 exponent, so I need to leave the y in the denominators to make it stay a positive exponent. And you can always check that by wherever the larger exponent is of the 2, that's where it's going to end up to keep it positive. And I would probably just write the answer like this. All right, next one. All right, so when I look at this, it's a subtraction problem. Again, you still have to have the same denominator. Even though it is something larger, it's a trinomial, these trinomials are exactly the same. So I do have the same denominator. So I can go ahead and write this with its common denominator. And now I am going to subtract the numerator. So I have a like term minus this like term. So 8 minus 5 gives me 3t. And then I have 5, positive 5, minus a negative 7. Positive 5 minus negative 7, which makes that plus 12. Now, this is the difference of those two fractions. Now I need to see what I can simplify. So in the numerator, I see that I have a GCF. So I take out 3t plus 4. And in the denominator, I'm going to factor the trinomial. And I have t plus 4, t minus 3. And so this would cancel, and I'm left with 3 over t minus 3. Some people might think the 3's cancel out, and they do not, because 3 was one of the factors. T minus 3 was another factor, and they have to be exactly the same in order to be able to cancel them out. Okay, now, what if they have different denominators? So here I have a trinomial, here I have a binomial. Obviously very different. So I'm going to factor this to x plus 3, x plus 2. X plus 2. And I can see these are the two factors that made up that trinomial. I have one of those factors right here. So in order for this denominator to look like, this denominator to look like this one, I need to take that x plus 2 and make sure it's multiplied over here as well. So I am going to write x plus 2, and whatever you do to the denominator, you also do to the numerator, because this is the same thing as 1. X plus 2 over x plus 2 is just 1. So multiplying a fraction by 1 is not going to change the overall fraction itself. Okay, the value of that fraction. So I'm going to do some work underneath here. I am going to go ahead and rewrite this with my factored denominator. And now okay, here we go. Alright, so now I have the same denominator, which is good. Go ahead and write that in my answer. Alright, and now I'm going to subtract like terms. Can't do that though because I want to take care of this first. So I have 5x plus 10. So I have x squared minus no other like term, so write x squared. I have 2x minus 5x. That would be a negative 3x. And then I just have that nothing minus positive 10. That minus positive 10 is actually going to make that a negative 10. And now I'm looking to see what can I cross out. Alright, so now I've got to factor this. X minus 5, x plus 2 is my numerator. So x plus 2's are gone, and now I'm just left with x minus 5 over x plus 3. And that is it. Okay, next one. Okay, we're going to rewrite it so it's in the same standard form as this one. And I'm going to rewrite it one more time, taking out that negative 1. Now, I don't like the way this looks to work the problem out, so I'm just going to show you what I want to look at. Alright, so see how we have a k minus 6? We have a k minus 6, but this has that negative 1 in front. So that must mean this needs that negative 1 factor as well. So that means negative 1 and a negative 1. So now this becomes negative 4k over negative 1 times k minus 6 plus k over negative 1 times k minus 6. All I've done is taken it from here and rewrote it over here. Alright, these are like terms, so you end up with negative 3k and negative 1. Okay, it's getting kind of sloppy, but here it is. Now, this negative and this negative can simplify to a positive. And so your final answer is 3k over k minus 6. That's supposed to be a 6 there. So that is the final answer. Alright, let me show you a couple more. Alright, x over 2x minus 10 plus 1 over 3x minus 15. Factor this, I see 2 minus 5. Factor this, I see 3 and an x minus 5. So look at this. This has a 2, x minus 5. This has a 3 and an x minus 5. They both have the x minus 5. This one has a 2. This one has a 3. We need those numbers to be the same. 6 is the LCM. So in order for this to be a 6, I need to multiply the top and bottom by 3. So now this becomes 3x over 6x minus 5. In order for this to be a 6, I need to multiply the top and bottom by 2. So now this is plus 2 over 6 times x minus 5. Now they have the same denominator, and these are not like terms, so I have to write that as 3x plus 2 over 6 times x minus 5, which nothing cancels. There's no GCF, so I write this as 6x minus 30. And that would be your final answer. Alright, last one. Something scary with all variables. Factor this. You end up with c minus d, c plus d, because it's a difference of 2 squares. This only has a c squared. This has a difference of 2 squared. So this one needs to have all this. I need to get that c squared over here as well. So that means I got to multiply the top and bottom by c squared. However, this needs both of these factors. C minus D, C plus D. And I have to do the same thing to the top and the bottom. So now, C times C squared is C to the third over, this is my new denominator, plus this is going to be D times all over okay, hot mess, but we'll get there. Alright, so this, I know what this looks like, not the D in front of it, but I know that this is a difference of 2 squares. So this goes directly back to this. And then it's got to be multiplied times D, so I know when I do that, it becomes C squared D minus D to the third. Alright, so now C to the third plus, are there any more C to the thirds? Nope. So now I have C to the third plus C squared D minus D to the third, all over C squared times C minus D times C plus D. Let's go ahead and get some simplifying here. We again know that this is going to be a difference of 2 squares, so it's that C squared minus D squared being multiplied times the C squared. So we have numerator stays this, and then C squared times C squared would be C to the fourth, minus C squared times D squared would be that C squared D squared. And that is it. That's all you can do with that. What's horrible about this is that it's all variable, so and nothing really canceled out. So that's as far as you can get with this. Now, I don't think I gave you anything like that in homework, but I just was looking at that as I was looking at some examples out of the book, and I thought, ooh, I maybe need to show you one. Okay, that's it. Good luck on your homework. Come back with questions. If you don't remember, they were pages, I want to say 14 through 19 on that section, and then 9, 10. I can't exactly remember the numbers on that one right now off the top of my head because it's not in front of me. So phone a friend if you can't remember what problems to do from this page. But get as far as you can with it. At least try to get the common denominator, and then if you struggle with what to simplify from there, let me know. Come with questions tomorrow. All right, good luck, guys. See you tomorrow. Bye.